Greetings. I'd like to look at the Isosceles triangle theorem. This theorem tells us that if we know two sides of a triangle are congruent, then the angles opposite those corners are also going to be congruent. So let's look at a diagram of this. If I start with a triangle, and I know that this side and this side are congruent, then the opposite angle here and the opposite angle here will also be congruent. That's what this theorem tells us. But it will also be true, the converse holds of this theorem, that if you know that you have two angles that are congruent in a triangle, then the opposite sides will also be congruent. So we can state a second theorem based on this first one, in which we reverse the clauses of this first one, and so it will be the converse of the stated theorem here. All right, the converse of the isosceles triangle theorem is telling us if a triangle in the plane has congruent angles, then the sides opposite those angles are congruent. So in this case, here is our triangle. And first of all, we know that this angle and this angle are congruent. Then this side and this side up here will be congruent. Now you may realize that this will apply to another type of triangle as well as the isosceles triangle. This will also work for the equilateral triangle. If you apply the isosceles triangle theorem twice to an equilateral triangle, you can establish that all the angles will be congruent to each other, and then all the sides will be congruent to each other. So this leads us to a couple of corollaries. I want to take just a minute or two and look at the different terms lemma, theorem, and corollary to help people get an understanding of how these words work. All three of these things are ideas that are based on some kind of an observation, a conjecture, and they all require a proof. So they're not a definition, and they are not a postulate or axiom. A lemma typically precedes a theorem. The theorem is usually like your big focus idea. So we'll call this the focus idea. And a lot of times you'll have a lemma prior to a theorem to help you with the theorem. So this is kind of like a helping idea. And then the corollary follows from the theorem. Once you've got your main idea, more ideas come to you. You think of ideas, just like in the last example, we saw that the isosceles triangle theorem would also apply to an equilateral triangle. So that is a new idea that comes from the focus idea. So this is a new idea from our focus. So this is kind of the hierarchy for these things. We have lemmas help us to get to the focus idea, the big theorem that we want to prove. And so you prove the lemma, and then you use the lemma to help you prove the theorem. And then after you prove the theorem, you might have some other ideas that kind of follow naturally from the theorem, and you might use the ideas in the proof of the theorem to help you prove the corollary. All right, the first corollary I want to look at, the equilateral triangle corollary. The first one is that a triangle is equilateral if and only if it is equiangular. I have the contraction here, IFF, that stands for if and only if. That means this is a biconditional statement. You could read it just as well from left to right as right to left. You could have read it as a triangle is equiangular if and only if it is equilateral. So starting with a triangle, we want to show that if it's equilateral, it's equiangular, which means equilateral tells us that all the sides are known to be the same. Applying the isosceles triangle theorem, we know that this angle and this angle diagonally will be congruent. But if I look at this from the side, if this is now the new bottom, or the base, and I look at it this way, this is a side, and this is a side, and as I look this way, this angle and this angle will be congruent to each other. And then as I step back and I look at the whole thing again, I see that starting with knowing that all the sides are the same, I can apply the isosceles triangle theorem twice and find that all the angles are the same. So if I know that it's equilateral, then I know it's equiangular. A similar argument will allow you to complete the proof for this and argue that if you know all the angles are congruent, then you can know that all the sides are congruent. Our second equilateral triangle corollary tells us that if a triangle is equilateral, then all of its angles measure 60 degrees. From the first corollary, we saw that we could start with an equilateral triangle and argue that all the angles were going to be the same angle. Well, how is that going to occur? We know from the triangle angle sum theorem that there are 180 degrees interior to a triangle for its sum of angle measures. Well, now I need to divide this evenly by 3. That's going to give us 60 degrees, and that's a little bit of the beginning of the proof ideas that you need to make this work. Hopefully this has helped you in understanding these theorems and these corollaries and how they relate together, and given you some ideas of how you might prove some of the ideas that are talked about here. Certainly, I haven't touched on all 4 of these ideas with enough detail. Take a little time and work them out for yourself if you want to get a better understanding of how these things work. Cheerful calculations.